So in the last period, we have discussed on the formation of p-type semiconductor and formation of n-type semiconductor. Then we have also seen the construction of p-n junction diode. Now in this topic, we are going to just explain what are the VI characteristics of p-n junction diode. Now in the diagram you can see that there is a circuit where the diode is forward bias here. How forward bias? Because see, the voltage applied has a positive terminal which is connected to our potentiometer, and the potentiometer then after it is connected to the p-type semiconductor of the p-n junction diode. What about the n-type? N-type of the diode, it is connected through a milliammeter through a current limiting resistance to the negative potential or negative terminal of the battery. So in this way we can say that the diode is forward bias. So we have to take the readings of applied voltage to the diode and the current flowing through the diode. So the relationship between the applied voltage and the current in the diode, that will give the graph, and this graph is called as volt ampere characteristics of p-n junction diode or VI characteristics of p-n junction diode. Now when the applied voltage is applied, and if this voltage is varied from 0 to in increasing order gradually, then what will happen to the voltage and current? Let us see in the graph. When the voltage is gradually increased from 0, there will be a very less current which will increase, and this less current is increased is due to the minority charge carriers present in the p-type and the n-type. So though the diode is not perfectly forward biased, it means perfectly forward bias means the depletion layer is still present there, and if depletion layer is present, there should not be any current which will pass through the diode. But due to minority charge carrier, there will be leakage current, and that will be due to the minority charge carriers. So here up to reaching the potential barrier voltage, there will be a very less current which will increase when the diode is forward biased. So if the voltage is now up to 0.7 volt, if the diode is suppose of silicon type, the potential barrier present in the silicon diode is 0.7 volt. So up to 0.7 volt there will be very less leakage current, and as soon as the applied voltage reaches more than 0.7 volt, you can see in the graph there will be a sudden increase in the current. So there will be rapid increase if the applied voltage is more than 0.7 volt. So this 0.7 voltage is mainly called as the knee voltage, or may be called as forward breakover voltage. So after this voltage, the diode will start forward bias and it will start conducting. So this was about the forward biasing. Now let us take a look at the reverse bias. Now we can use the same diagram, and here you can see only small change is done, and this change is that the diode, the polarity of diode are now reverse bias. So you can see the positive terminal of the battery, it is connected to n-type, and the negative terminal is connected to the p-type. So now this diode is said to be in reverse bias. Now let us take a VI graph. When the applied voltage is in opposite polarity to that of the p-n junction diode, then if the voltage is gradually increased, again there will be a leakage current, and this leakage current will start increasing, but it has very less amount. So up to certain voltage there will be no conduction in the diode, only the conduction is due to minority charge carrier, and that current is leakage current. So here what is happening, when the voltage is increased, the depletion layer is getting wider, so the junction resistance is getting increased. So as reverse voltage is increased from 0, reverse current also getting increased. So equal reverse saturation current will be there, and when the voltage is increased further at a particular voltage, the current may increase rapidly. And this voltage where the diode start conducting in reverse direction, that voltage is called as breakdown voltage. So when reverse voltage is less than that of the breakdown voltage, the diode will offer high resistance and it will act as an open switch. So no current up to breakdown will be possible when the diode is reverse bias. So this was about the diode when it is in reverse bias. So this was about the characteristics of PN junction diode when it is forward bias and reverse bias. Now let us take a look at the applications of PN junction diode. Now where this device is used. This device can be used as a switch because when it is forward bias, it will act as a closed switch and it can offer very low resistance and there will be a passage of current through the diode. So this switch, this will work as a closed switch. In the similar way, if the diode is reverse bias, it will offer high resistance for the passage of the current through the diode. So it will act like a open switch. So diode can be used as a switch. Another applications of PN junction diode is that it can be used as a rectifier. Rectifier is a circuit which converts alternating current into the direct current. So the diode allows conduction only in one direction, that is when it is forward bias. A rectifier is a device which converts alternating quantity into unidirectional quantity. The alternating quantity may be current or may be voltage. So diode can be used as a rectifier. These rectifiers are classified into two types. Either it can conduct half cycle or either it can conduct the full cycle. In both the types, the current direction will be same. So it is unidirectional. So both the rectifiers will convert AC into DC. The half wave rectifier has only one diode, while the full wave rectifier, it is again classified into two types. Full wave rectifier using two diodes and a center type transformer is the one type, and second type is the rectifier which uses a combination of diodes in a bridge fashion, and that rectifier is called as a bridge rectifier and it uses 4 diodes. So these are the applications of PN junction diode.